The simple way to think about a problem like this is to think about division. So we know the number 8 has two factors, right? 4 and 2. Now the reason why they're factors is because I can rewrite 8 as 4 times 2. Right? Factors are going to multiply to give you a number. I can also rewrite this as a division statement. I can take a factor, divide it into my number, and I'm going to get another factor, right? 8 divided by 4, which is a factor, is equal to 2, which is our other factor, because 4 times 2 is equal to 8. So I'm dealing with polynomials, and I want to know, is x plus 2 a factor of this polynomial? Then I simply need to know, does it evenly divide into the polynomial? And if it does, the quotient is also going to be a factor. So let's see if this divides into that. To do that, I'm going to go ahead and use synthetic division. I'm going to use the opposite of my divisor, so I have an x plus 2. Therefore, I'm going to have a negative 2 here on the outside. Then I'm going to take the coefficients of my dividend or my polynomial, and I'm going to rewrite them up along the top. So I have a 1, 2, 3, and 6. This is dividing x plus 2 into this polynomial. Now apply the synthetic division algorithm. The first term always comes down. That's a freebie. Now you're going to multiply on the diagonal, add on the vertical. 1 times negative 2 is a negative 2. 2 plus negative 2 is a 0. 0 times negative 2 is a 0. 3 plus 0 is 3. 3 times negative 2 is a negative 6. 6 plus negative 6 is going to be a 0. That's my remainder, my constant, my coefficient of my quadratic term, coefficient of my linear term. So therefore, my other factor is an x squared plus 3. But most importantly, since when I divided this into my polynomial, I got a remainder of 0, I know that x plus 2 is indeed a factor.